Today we're going to talk about converting equations. Previously we've talked about the slope-intercept form of a linear equation, but there's also the standard form and the point-slope form. So the first thing we're going to do is talk about the equations before we start working with them. You're familiar with y equals mx plus b, where m is related to your slope, b is related to your y-intercept. Y and x are your independent and dependent variables. We know that x is always your independent variable, and y is your dependent. This is the typical equation that we work with. This is one of the most common ones for a linear equation. Advantages of this equation are that it's easy to graph, your slope is given, and your y-intercept is given, so you can very easily see those from the two equations. A disadvantage is it's not always easy to write this equation from a word problem, and that fractions and decimals can make it hard to work with sometimes. Your next equation that we have is the point-slope form. Now, this is not a common equation to use, but it does have its advantages. So looking at the equation, y minus y1 equals mx minus x1, you can see some familiar things. You see your m first off, and m still stands for slope. Your y and your x are still your independent and your dependent variables. Your y1 and your x1 are from a coordinate. So it's just any coordinate, and we're just calling them y1 and x1 just to identify that that is an actual known coordinate. But if I were to say 4, 5, then you would use 4 for your x1 and 5 for your y1, and you substitute them in like we have been doing previously. Some advantage of this one is that it can help you find slope-intercept form if you know one of the points on the line, and it helps when you can't find slope-intercept form. Okay? It is not easy to graph at all, and it's not very commonly used. Those are some of the disadvantages. The last equation that we have is the standard form of an equation, and this is very common. It is ax plus by equals c. Your x and your y in this case are both your independent and your dependent variables. It is very common. It's easy to find your x and your y-intercepts if you know what you're looking for. And it is perfect for systems, and this is our next unit that we'll be moving into. Some of the disadvantages is that your slope and your y-intercept, they are there, but it's not easily seen. And you must convert it to slope-intercept form in order to see your slope and your y-intercept. So those are the three equations that we're going to be working with. From here, we're going to take some information, and we're going to move them in between all three different forms of the equation.